Bismillahirrahmanirrahim. Iyyaka na'budu wa iyyaka nasta'in. Today I am going to present our final year project, which is hand gesture recognition for sign language. I am Syed Farooq Hasnain Hashmi with my group mate Mansoor Ahmad Khan under the supervision of Dr. Junaid Ahmad Bhatti. Now, this is the outline which will be followed throughout this presentation. Start from introduction. As we all know, dumb and deaf persons confront a number of challenges in the workplace, including difficulty interacting with the system because they cannot hear it, and the risk of going somewhere alone because they cannot hear cars, motorcycle, or other people approaching them. It is pretty hard to crack for those people who cannot hear, who cannot see. Okay, so if someone is crossing the road, so it will obviously they cannot hear it, the sounds of car and motorcycle or other people approaching them. They are unable to adjust their surrounding fast and are unable to react to other regular individuals, making it difficult to express themselves. Now coming toward the motivation. Motivation for gesture recognition is to develop a system which can detect your gesture, and these gestures are widely used for conveying your information. So this is all about our motivation. Coming towards problem statement. As we all know that it is a hard nut to crack for especially able people to communicate with one another. In order to make communication easy, these projects help them a lot significantly. Now, in this project, we did so many research and we also followed so many research papers. So we summarize, or we can say we come up with 3 literature review or research paper. The first one is color-based recognition using glove maker. So in older days, in previous days, gloves were used to detect the information, or we can easily convey the information from one person to another. But as it has some limitation, it has some disadvantages as well. So as we are using glove, so one person have to wear glove in order to communicate with another person. The second thing is, the second disadvantage of this research paper is everybody has his or her own skin sensitivity. So this will make skin diseases as well. Now, the second thing is hand gesture recognition using multiple acoustic measurements at risk. So as this research paper suggests us, by wearing watch or wearing some anything in your wrist, we can easily detect our gesture, or we can easily convey our information. But it has also some disadvantages. So that is why we choose another research paper. We also studied it. So the best we found is hand gesture recognition based or on computer vision approach. As you all know, computer vision is a sensor. We can say a sensor. Computer vision sensor means we are using a camera approach. By showing the gesture in front of the camera, we can easily convey our information. So this technology has inside 2 basic recognition: skeleton based recognition or depth based recognition. So coming towards aims and technical objectives. The technical objectives of our project is to accomplish hand gesture recognition by vision sensor. As I told you, vision sensor such as camera. This is one of the most important technical objective of our project. So we want to learn, a camera, how to interact camera with artificial intelligence, or we can say a machine learning. So we keep this technical objective in our mind, and we also want to learn communication convolutional neural network. So this is our technical objective. Coming toward a general objective, we are having a general objectives as well, to develop a virtual talking system, to develop a system that can recognize distinct human gesture and utilize them to communicate. Now, one of the most important general objectives is to implement it in special schools. As we all know that in special schools, there are children who cannot hear. Some children cannot hear the voice, some cannot hear the sound, some cannot see. So we can, our objective is to implement our project in those schools which can, by using our final year project, they can easily convey their information or start their conversation. Now, coming towards the methodology, we implemented 27 plus 10 symbols. Now, I'm going to tell you which gestures are there. One, there is blank. If there is nothing in front of the camera, your camera will show you, our final year project will show you a blank sentence. Okay. If the now after blank, there are some American Sign Languages, which is showing in this presentation. This is called A. This sign is called A. This is B. This is called C. This sign is called D, and so on up to the Z. So this all 26 gestures plus blank. This is called 27, and we also implemented 10 common gestures such as I'm fine, thumbs up, thumbs down, victory signature. This is, we use it commonly in our daily life. So we also implemented it. This is our flow diagram of our project. Image frame acquisition, hand segmentation, tracking, feature extraction, classification, and after this, there is an output. Now, as I told you, there are multiple stages of our final year project. So first step is image frame acquisition. In image frame acquisition, what we did, it is a process in which a gesture or posture of human body parts are identified and are used to control computers and other electronic appliances. What we did in image acquisition, in simple words, we can say in image frame acquisition, we did data collection. Okay, we collected so many gestures such as A, which I show you in previous slide. This is called A, this is called B, C, and up to Z. We captured so many pictures at every angle, at dark mode or in light mode as well. So we captured so many images of American Sign Language or common, which is 10 gestures, common gestures. We also captured the image of that. So we captured it and save it into one file. Now the second step of our final year project is to pre-processing. As you all know that everybody has not enough computational power, or we can say everyone does not have a computer which has powerful processor. So to overcome this problem, we convert our image, because image is colorful image, and in colorful there are three channels. In colorful image there are three channels: R channel, G channel, and B channel, red, green, and blue channel. So this will take more computational power because there are three channels. So what we did, we convert these three channels into a single channel, which is called gray modeling, or we can say in black and white form. So in simple words, I'm going to tell you that in colorful picture, we convert that colorful picture into black and white picture. Coming towards hand segmentation and tracking, this is also one of the part of our project. Texture that segments out the portion of the camera feed where the hand is. The gesture of A, this is A. This is a gesture of A. So what we did here, we apply thresholding technique. What is thresholding technique? Question arises in your mind. So thresholding technique is a process which, this is called A. So which will create a boundary of your gesture, or we can say the outline of your gesture. Okay, or we can say a device monitors movement frame by frame to capture every movement and provide accurate input for real-time analysis. This is also, this is called tracking. Now coming towards feature extraction and classification. The process of transforming raw data into numerical features. Now, in artificial intelligence, there is ANN and CNN, artificial neural network and convolutional neural network. In artificial neural network, we give the input as an image, as a number. The input we send is number. So for complex, or we can say the image, for image, if we are using image as an input, so we use CNN for feature extraction. This is the technique which we used in our final year project. The process of transforming raw data into numerical features. I will explain later on what is CNN. Now coming toward the classification. This is an algorithm that is used to predict what category data belongs to. Okay. Now, as I told you, I will tell you what is CNN. So, coming towards convolutional neural network, CNN consists of multiple convolutional layers, each layer containing numerous filters. Now, as I told you, in artificial neural network, we give input as an number form. If we give input as an image, artificial neural network cannot extract their feature. So to overcome this problem, before artificial neural network, ANN, we develop a layer which is called convolutional neural network, containing numerous filters which perform feature extraction. Initially, these filters are random, and by training our data, or we can say the model, the feature extraction gets better and better. It's primarily used for image classification, or if you are using your text as an input, so we will not use CNN. We can use it, but we will not use CNN. We will use RNN. Now, autocorrect feature, in the last part of our project, and one of the most important part in my point of view is prediction. Now, as you know, that in American Sign Language, there are some resemblance, such as in A or M, we can say there is a lot of resemblance. Okay, so it will, if you are trying to show you M, it will show you A, or if you are trying to show you A, sometimes it can show you M. This is sometimes, I am telling you, sometimes it will show you, not always. Okay, so to overcome this problem, because in final year project, when you are going to implement it, you are going to have so many problems. So to overcome that problem, we are using a Python library, HunSpellSuggest, which is used to suggest correct alternatives for each incorrect input word, and we display a set of words matching the current word, in which the user can select a word to append it to the current sentence. This helps introducing mistakes committed in spellings and assists in predicting complex words. Now, there are some limitations of our model. The model works well only in good lighting conditions. Plain background is needed for the model to detect with accuracy. Now, coming toward the results. This is all the results. As you know, this is the gesture which is showing, which is give you the information that I am fine. This is American Sign Language gesture, which is called A, and this is also American Sign Language gesture, This is which is called F. Now coming towards cost estimation, because we are going to implement in practically, so there is some cost estimation. The equipment we are using, we will be used camera, Raspberry Pi, accelerometer. We are, if you are not having a PC, then there is you have to connect Raspberry Pi with your camera. So camera, which is about 7,000 price, Raspberry Pi, which is about 7,600 rupees, accelerometer, which is also called a sensor, which is called 500 rupees. Now the total estimation of our cost is 25,100 rupees. This is called. Now coming towards confusion matrix. As you can see, there is alphabets from A to Z. Now you can also see these numbers 147, 139, 152, and so on till Z. Now this will show you the accuracy. Confusion matrix will tell you about accuracy of your alphabet, of your American Sign Language, that how much your project or how much your data is accurate. Okay, such as A will present 147 times. Okay, accurate. This is tell you the accuracy about A, but sometimes it will display M, sometimes it will display N, sometimes it will display 2 as well. So this is called the accuracy. The same thing is for B, the same thing is for C, and up to Z. So now this is our FIP video. I will show you this. Now you can see this, there is a danger, stop now. Okay, this is B, this is a gesture of B. Okay, now this is the gesture of F. As I told you, there is, sometimes, there is a repetition of word. Okay, so this will tell you about the accuracy of your project. In previous slide, I told you about the confusion matrix. So this is all about our final year project. So coming towards the conclusion, in this project, a functional real-time vision-based American Sign Language recognition for dumb and mute people have been developed for ASL alphabet, American Sign Language alphabets. Prediction has been improved after implementing 2 layers of algorithms in which we verify and predict symbols which are more similar to each other. Now, coming toward the future recommendation. In future, we can add more specification, like make it able to translate a complete phrase rather than to show you a single word, and by containing those single words, you can easily make a sentence. To overcome this, in future we will like to implement to translate a complete phrase and create a mobile application which will directly translate sign languages to text, and which can help you a lot for people. And this is the references which will be used in throughout this presentation or final year project. So this is all about our presentation.